So now we're finally looking at a setup over here that promises to be a bit more advanced than those that we've looked at until now. So the simple setups over here. Now, first of all, I can already tell you this setup here actually does what it says on the tin. It will allow you to grade across the AOV sets, which is what we want, since that gives us a great flexibility, and it does so by mixing both the additive and the subtractive methods in a way that actually works. Now, as a result of that, I've chosen to call this a combined additive and subtractive method, or setup. Now, I suppose you could also call it something like advanced subtractive method, but I think I'm just going to stick to combined for now. Okay, so this is the point where I can tell you that it would probably be a good idea for you right now to hop into your kitchen and grab yourself a coffee, because this setup is going to take a while. There are lots of things to cover, and my hope is that to go through this setup, both as you're seeing it right now, as well as the, in inverted commas, the fixed version of the same setup later, to go through that in detail will make reviewing the next setup type, because there's still one to go after this one, a little easier. Here is how I plan to progress through this part of the tutorial. Number 1, we're going to have a quick run through the setup to find out how the data flows. Because in comparison to the other two previous setups, at least on the surface of things, it's not as easy to see what's going on over here. Yeah, we're going to have to do that. Secondly, we're going to walk through the rebuild portion of the setup. So that will be where we rebuild our beauties, would be over this side. And we're going to go through this portion of the setup step by step to find out how this method of combining both additive and subtractive principle actually works. And then it will be time for a quick test of its functionality, because of course we do want to verify that things work. And after that, we can then move on to go through a variety of miscellaneous things in the setup that I would like to talk about, address or change. I guess one example of that would be that I think I will spend a bit of time talking about matching blacks, as well as depth grading in relation to how it's been implemented in the setup. Okay, and then we can move on to the fixed setup, where we'll review what I've changed about the layout, check out that things still work according to the same principles, and a bunch of other things as well. So, and then at the end will come the time to really test the setup, and I can already tell you that we will bump into one issue that is problematic, even though the setup actually works, and understanding that issue will serve as a kind of bridge to the next and final method of setting up grading templates for CG that we will explore in this tutorial. So already from that to-do list, you can tell that this is going to be quite a long ride. Now, I will progress in sections, but as I said, it's probably a good thing to grab a coffee for this one. So first off, you are again looking at a setup based on one from an actual production. And if you look over here, hopefully you can see this, I've labeled this combined additive and subtractive method, and I've also written not optimal in terms of our requirements. So maybe it's time for us then to quickly reacquaint ourselves with these requirements. You should see them overlaid on the screen right now, and if you wish to really take the time to read through them properly, you should pause the video to do so, because I will simply move on. Off the bat, one thing that I really like, if we just move in a little bit closer here, we can see that we have clearly labeled backdrops. We see that we've got beauty from lights, from materials, from direct and indirect light, as well as the utility section over here. And this, in terms of overview, I think is a really great idea. So let's stick to clearly labeling things from now on. And of course, the thing is, though, if the backdrops here really do contain what they say that they do, well, that's another matter. But that, again, would be the responsibility of every comper to actually go in and double check that it is indeed the case. Okay, data flow. Let's start at the top over here, where we have CG in, because that seems like a nice place to begin. And I'll admit that when I first had a look at this setup, very quickly, I was too fast or too stupid, because I thought I could just basically trace the data going from CG in straight down and find my output down here. But as you can see, that's definitely not the output. You can see from these numbers, all we're getting here are zeros. And we have a note here to tell us what this really is. If black, you're good to go. If not, check if there are new lights or a light pass has a different name. So what these three things are, you can see that they are all connected. They're not basically connected to each other. They're all connected to this one input, or not input, but this dot here with one, which is our rendered beauty. these are checkpoints. And we have 3 of them. So we got the second one and the third one. So if I flip now, you can see, whoops, second one here. So 1, 2, 3. Yeah. So they're checking these AOV sets, basically. And since we get black, black, and black, we can say that that basically should mean that our AOVs coming in here and the way they've been set up should be fine, according to this note. Okay, so the checkpoints, but let's rather try and follow the main data flow then. Since this is not it, we're obviously not going to go to the utility section. We're also not going to go over here because that is where we have our shuffle nodes. So the data kind of has to flow down here and over to the right to this merge node. And here you can see something that you probably already recognize from our simple additive setup, this sort of almost black frame. I'm going to get into that later again, but for now we're just following the data. You would, you would probably guess that this here is where it goes next, and you would be right because it does have a connection, even if it doesn't appear to be so. And this is basically a hidden connection. And I guess we should just have one thing we need to say about hidden inputs. Yeah, you will have seen that I like to work with them. I'm using stamps pretty much in every comp that I do. And you're going to find a lot of hidden inputs with stamps or using stamps in this setup as well. Now, the way that they are used here, though, is not something I'm very keen on. When I'm trying to find out how the setup works and how the data flows, I want to see basically where my data flows. And by having hidden inputs in this way, they're actually hiding something that I want to see. So that's not the way that I would want to use these hidden inputs. And I don't think this is optimal, so I think I'm going to change this in the fixed setup. But let's move on. So we got this almost black frame here, and you can guess right if you're guessing that the next point is where we have our first reconstruction, or basically the first rebuild of our, in this case, Beauty from Lights AOV. And from there, we are then going to go to the right because this is a checkpoint. And yes, again, we have more hidden inputs, but we can see that we're following the B pipe. So we got another black frame over here. And now the data goes to the right the whole time. Yep, another black frame. And then here we have a reconstruction, and that would basically be the final result of all the rebuilds of all the AOV sets. And then it's pretty simple to see that the data then just basically flows down, 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 gets pre-multiplied, and we go to CG out. Okay, so it's basically down to the right, down to the right, down. And this kind of zigzagging is not something I'm very keen on. I don't think it makes for a great overview of your setup or for, good layout in that sense. So I'm going to have to change my layout to accommodate for these requirements or these guidelines that we had, to make it look a little bit more like these, where we have where we basically have a predominantly top-down setup, and we have a B pipe that is very well defined, and in this case, and as well as in this case, is going just basically in a straight line from the top to down. So I'm going to have to change the layout of the setup quite a bit, I think, at least in terms of the placement of the various elements. Next up, we'll look at how the reconstruction of the beauty in this setup actually works. Okay, so we can start at that first black frame that I said that we know from our simple additive setup. This one here. Let's put our viewer on one here. So we know that this had something to do with the additive setup earlier. In fact, we recognize what this is, of course, because we're doing the exact same thing over here. Put that on 2. And I flip back and forth, 1 and 2, you can see that actually this is the same thing that's going on. It is the part where we subtract in order to get the difference between the summation of our passes, so a rebuild using only the AOVs, and the actual beauty. So basically here is the rebuild using just the AOVs available to us. And, this is a plus operation. And here, so it's here, and then on 2, we can put the beauty. So the difference, the result of a subtraction operation between the two will result in the difference between the two. And this difference exists because of how the beauty has been denoised in the renderer versus how the individual passes themselves were denoised. Another important thing that we found out in the additive setup is that we have to have, or we have to allow for, both positive and negative values, where the positive values represent brightenings of pixels and negative values represent darkening of pixels, with a reference to the rebuild we're doing using just AOVs. So, you can see here, we got negative values, and if we can find one, yeah, we got positive values. So those are both needed at this point here. So we've been through this already in the first setup we did, and I shouldn't have to cover this in very great detail. So let's move back to the current beauty, or not the current beauty, but the current setup. So we know now this is basically the same point as what we just showed in the simple additive setup. One crucial thing to mention is that had we not had any issues with denoising or noise patterns, etc., we would at this point here simply get a completely black frame. So from now on, for the sake of argument, I will simply refer to this here as our black frame, even though I know it's not completely black in this particular case with this particular render for the reasons I just gave you. So what is important to take from this before we move on then? Well, the black frame, due to the subtraction, creates a foundation for us, or a baseline is probably a better term, of 0 or black, around which we register differences in both the positive and the negative domain. This is important to remember in order to understand how the whole setup works. So what is then the next thing that we do? Okay, because we now have a black baseline, or a baseline of 0, we can simply add the reconstruction of our first AOV set on top. So basically the summation then of all of these, we can simply plus them on top of this black frame that isn't quite black in this case, but as I said, for the sake of argument. And that should give us our first reconstructed beauty. Basically, a reconstructed beauty based on the beauty from lights, or basically the light group AOVs. And we already tested this in the checkpoint earlier to verify over here. We got complete, we just have 0. So we verified that at this point we are identical with our actual beauty. So as a result, I'm going to call this point here, or rather, here, I'm going to call this our current beauty. And that means that we have now been through the first section, this here, of our setup. And as you can see, it is an additive setup aided by the black frame, or the 0 value baseline. So to reiterate then, we have a baseline of 0. So we have a baseline of 0 here. We add our AOVs on top via a plus operation, and we obtain this beauty reconstruction for the first part of the setup. This is all good, but how does it then connect to the rest of the setup? Well, if we move on, we see that the next merge is also set to a from operation. So let's move on then. We are here, and here we can see we got the hidden inputs. This one is also set to a from operation, so it too is doing a subtraction. And this means that at this point we're doing a comparison between the current beauty and up here, so if I do this, the current beauty, and up here, the second AOV set, which in this case is the material AOVs. And we are registering the differences between these two sections up here, centered around the pixel value of 0. So therefore we have created a baseline again. And let's just call this then our current baseline. It then follows that on this current baseline, we can once again add the AOVs from the second AOV set and again obtain another reconstruction of our beauty, which is happening here. They're first merged together with a plus, and then they're added on top, and there we have a beauty reconstruction again. So here we see that we have effectively now chained together the first and second AOV sets of our render. And the important thing to note is that because we're adding our AOV sets on top of black, we don't overshoot any values. So for example, imagine if we had just added one AOV set on top of another. Because they both reconstruct the beauty, we would end up with values double that of the original beauty render. But since we're adding on black, we are always getting the same values as the beauty. And that is the key. Subtract the black, then add back to beauty. And here we can also see how the current setup is somewhat different from our previous simple subtractive setup. So let's go over here, let's have a look. High key, okay. you will remember that in the simple version, we start with the beauty here, then we subtract some information, based on one of those passes, one of those AOVs, and then, so that will be in this from operation, and then we simply add that same information back on top of this result here. Okay? That's really, really straightforward. And if we now grade the AOV, oops, so let's go here. Yeah. So now if we were to grade the AOV, let's just grade it up. Well, what are we doing now then? We're still doing exactly the same thing, but what we're adding back in here now is the graded AOV. Okay? So it's still really straightforward. This, however, so we can delete that. This, however, is not really what's going on here with this setup. Though we are using a subtractive process, the whole point about the combined additive and subtractive setup is that here we are collecting differences, and they are registered around our baseline of 0. And what will one of those differences be? Well, our grades, of course. They too will register on our black frames, where positive values will be grades or represent grades for brighter pixel values, whereas negative values will be representing darkening of pixels. Okay? So it's not really the same as the simple subtractive method then, but it is indeed this collection of differences that allows us to chain together the AOV sets that we have done here now. So in this case, right now, we've chained together the first and the second AOV set. So let's move on to the next step. And you might be a bit surprised to see this. What's this? As you can see, this time we don't really have a black frame in the same way that we had previously, at least, technically speaking. So what's going on? What is happening is that, as you've probably guessed, we are missing a couple of passes, because that's what it looks like. We are, and I actually know which one it's going to be, so I can show you here. We are missing the subsurface scattering, or information from the subsurface scattering, as well as from the transmission. So, okay, if I look over here, and I set this to plus, and then I basically have this on 1 and this on 2, you can see, so this part of the image around here where we see near black, that looks very similar to before. And as you can see, we actually have these 2 passes missing. Okay, so what's that about then? Well, when I was rendering this image in Houdini, I was only going to output AOVs that I could access really easily by just a tick box or a couple of clicks. I did not want to spend any time trying to create some kind of custom AOVs. And as for the direct and indirect lighting contribution AOVs, well, I did not have access to these for those 2 mentioned passes that we can see here. So they're simply not rendered. Now, the interesting thing, though, is that although this particular AOV set is technically incomplete, because we are collecting the difference between the current beauty, which will be here, and the summation of the AOV sets up here, because we're doing this, we are picking up that missing information here anyways. And this means that the setup actually still works, which is great news for us, of course, because it means that when we add this part here, and here you can see, that there's stuff missing on these 2 heads. So it means, again, that when we add or plus in this rest of the AOV set, we still get a beauty reconstruction that is identical to the rendered beauty, and we have managed to chain together all 3 AOV sets. And we know it's identical because we have this checkpoint over here that says black frame, and that means everything is good. So that's really brilliant. Okay, so overall, you might wonder about how this differs from the simple subtractive setup, apart from the way the subtraction process works here that we just went through earlier. Well, in the simple subtractive setup, this one here, we are rebuilding our beauty per single AOV. And we can do that as many times as we like, remember? And here, though, we are rebuilding our beauty using a subtractive principle, but we're doing it per full AOV set as opposed to a single AOV. And that is an important difference in the end. So hopefully now you have a good understanding of how all of this works. It's all about that difference over the black baseline. The next thing we need to do then is to actually quickly verify that it really does work. So let's add a few grade nodes. Let's go in here for a second. Let's see if we can find one. Okay, so let's start with the, what is this? This is the top fill. Yeah, let's put one here. Let's put one here. This is the diffuse. That's always nice and visible. And let's try this here, which should be our indirect emission. Yes. And then we'll just have a look down here at the output, CG out, so that we know that we're viewing the final result. Okay then. So let's start with doing a bit of grading here. As you can see, we can grade up, we can grade down. And let's do a brighter image for now. And then the second one, we can grade down, we can grade down, we can grade up. That's all good. Down, up. And that is the diffuse, if I remember correctly. And then the final one, I'll do that one as well. You can see it's not quite as strong a response, but we do see it around these areas here that we are getting a nice result. Okay, that's all good and fine then. As you can see, it's working. We can indeed grade across all of our AOE sets. And if we take a look at our black frame, so let's just go to the first black frame here, switch this off and on, we see exactly as predicted that the grades we are doing are getting registered as the difference between the current beauty, that will be here, and the subsequent AOE set, that will be here. And you can see that from the hidden inputs, how they're connected. You know, B here, coming from here, and then the reconstruction up here is in the A input. And if I go in here and I just have a look, so let's see, if I pull this down, we should be getting negative values. I'll pull it up like I did, we should be getting positive values. So that's great. That's exactly what I want. Also, as we progress down the chain, so this is the first part, we progress down the chain here, and then down to here, this is the next black frame, we can see that the differences that we're getting, they are accumulating. So if I turn this one off and this one off here, you can see that now I'm only looking, so at this point I'm only looking at the grade that I'm doing now. That's the first one. But of course I can turn on one grade further up the chain, and we can see that the differences here are accumulating exactly as expected. And they keep doing so until we reach this point with our final grade, where we can view effectively our final result. So this is exactly as this setup is meant to work. Now this means that I have now actually covered the entire reconstruction part of our additive and subtractive AOV setup. But of course, there are still a bunch of things I would like to address before I show you the improved setup. And that is coming up next. Let us have a look at a few things other than the beauty reconstruction that I would like to address. The first thing I want to mention is the merge node here. And actually it will be the same with this one and this one, but let's just stick with the first AOV set for now. This is effectively where we are doing the first part of our, the first additive part of our setup, right? Notice how this here is different from what's going on over here in the simple additive setup. Now, why is it different? Well, I'm using just one merge node over here, and over here I've got this daisy chain of many nodes. And we can verify here. If I pull this down a little bit and go down in, you can see we've got A1. So basically, as you probably already know, a merge node will take one B input and then as many A inputs as you would like. So basically X number of A inputs, and they will be labeled A1, 2, 3, and so on. All right, so they're all coming in there for the one node. And then you might ask yourself, well, if I can get away with using one node for the additive section over here, why not just use one node over here? Because if we look here, every merge node has just one B and one A coming into to it. And then basically the daisy chained horizontally like this. So why not do the same thing as I'm doing here? And another aspect of that is, remember that we set things up both here and here in order to make sure that we have real estate, the same kind or the same amount of real estate for our grading nodes, well, that problem has also been solved here in the sense that we've been pulling these dots down, or in the setup, the dots are all lined up. So here too, we have the same amount of real estate. So I guess that's another thing that this setup or this way of setting things up also solves. So therefore, using just one merge node seems like a great idea, right? Well, let me show you one thing. If I pull this down here, and actually let's do this. If I pull this down and I just unhook one of these things, one of these inputs, and I put this back again, I click away and zoom out a little bit. Can you see now that if I, or when I put this merge node back here, and from this distance, I have no direct way of seeing that some information, basically an input, is missing in my setup. So you can imagine a scenario where you have set up everything the correct way, you've checked the checkpoints down here, they're all black, everything is good, and then you start grading, and by accident you may unhook one of those A inputs without noticing that something is off. Now this would be bad, right? Well, I mean, of course, if you select something further downstream, you can see that because upstream kind of lights up, you can then see that indeed this one doesn't light up, so there's something missing there. And still, for my taste, this is not really visible enough. And if we contrast that with the setup over here, since each of these nodes only have basically one B and one A input, and if I then unhook one, then you basically have an open space because of that. No matter how far I zoom out, hopefully you can see this in the video, it's really, really easy to see that something is missing. You know, there's an input that has been unhooked or is basically, yeah, that is missing by most likely by accident. And so it's also very, very easy and simple to fix it. Whereas here, I would have to go in and look around a little bit more to find out exactly what it is that's missing. So that is one of the reasons why I do the horizontal daisy chaining and why I actually kind of prefer to do it. So let me just undo here until we're completely back to, yeah, this stage, everything is working. Good. However, using just one merge node is, of course, technically speaking, perfectly fine. So this change that I would like to make in the upcoming setup is really just a matter of preference on my part. And by the way, you know, for your information, I do, of course, use just one merge node in the upper part over here. I do use it here, as you can see, but that is kind of because this part of the setup is really only there to extract that difference. And so I'm not really expecting to do any work here or to touch this part at all. I'm much rather, or I'm much more likely to be, you know, touching stuff here and then by accident, you know, unhooking something. So, you know, it does save a few nodes and maybe a little bit of space. So that's why I did the simplification up here, but not here. Okay, so that is one thing. The next thing I would like to address is this section here. We can, first of all, see that we have a remove node set to keep RGB here. So what that means that until this point in the setup, we have kept all the layers in all the data streams above. We can verify that by simply looking here and see yes. So if I look here, I can see I have, you know, all kinds of passes, all kinds of AOVs available to me still. So until this, so basically up here, we have kept all the data, and then, you know, we get rid of them here. At least we do that. But of course, by now, you know that I like to get rid of these layers and channels as soon as possible, which would basically mean I would be setting that up right after these shuffle nodes. So this is something I will be changing in the upcoming setup. Okay, then we can see that we have a merge node right beneath it, and this one is set to an under operation, but crucially, it's also set to also merge all. Okay, so what's that about? Well, if we then take a look at the A input, because the B input is coming here, and if we take a look at this A input, okay, we see first black, but if we look over here, we can see that we have things such as our depth, such as our, you know, we got a normals in here, etc. So what does that mean then? Well, it means that what we're piping in here are a set of utility passes. And we're also crucially accessing, let's have a look to be sure, the alpha, which in this case, so you can see here, is just 1 because, you know, we have the backdrop in the render, and over here we can see that we don't have the alpha. We go down here, alpha is there. Okay, so we got utility passes coming in and we've got the alpha coming in. That's all great, but in order to facilitate that, we have to set this merge node to also merge all. And doing this at this point is actually quite good, because very often we will need to access, especially a depth channel, but also often a motion pass, for example, for doing defocus and adding motion blur, etc. after the grade. So then we can see that we have a copy B box here. What that's doing is it's just ensuring that the A input here will have the same bounding box as the B input. And that's really all that that's there for. So there's nothing really magic about that. Then, well, actually, let's have a look here. If, just one thing, if we look here, so I said we have depth, we have normals. So in other words, we have a few utility passes in here that are, to be honest, not really sure if they're really needed, such as the normal pass. I'm not really sure if I'm going to need that, because if I really would need it, then I could simply fetch it directly from my utility section that is here, or, you know, I have it up here as well. And I could do that on a case-by-case basis. So whilst I think it's a great idea for things like the Z-depth, I'm probably not going to pipe in all, you know, more than I need at this point. And then one more thing is that although I agree on injecting this pass, or at least the depth pass, I find it a bit awkward that it's been set up in such a way that if we look here, where we are collecting the utility AOVs or fetching them is right over here. We can see it. So the utilities are coming in, and you can set up, you know, set up the motion vectors, etc. Here we're getting our alpha in. So it's been set up all the way on the other side of the pass, or all the way on the other side of the setup, I mean. And I think it would make more sense to actually move them. Oh, let's do this a little bit better. To actually move them over here, something like this, at least for the sake of readability. So I think, although again, this is technically fine, I will probably do some changes to this section as well. Okay, let's move on. So after the injection of utility passes, we have this little section here that is labeled stencil. I'm not going to really spend any time on this one, because I think that in general, if I were to stencil out parts of the image, I would want to do this after the grading template and not as a part of it. And also in this setup, the stenciling is happening in an unpremultiplied state. So I'm not really sure if that is really the way to go. Now, it could be that there was a very specific reason for why things were set up in this way, but I can't really remember. So I'm simply going to delete this part from the upcoming reworked setup. So what now then? Okay, let's see. Yes. So we also have a couple of redundancies in our setup. First of all, whilst it is a great idea to have a utility section like this, I personally like, as I have explained to you before, to organize my data streams up here before I go into any kind of setup like a grading template like this. So as a result, we now have two utility sections. We have one up here, so you can see, and one down here, and that's basically one too many. My preference is to keep the one at the top and get rid of the one at the bottom. But if you were to create a setup of your own and you prefer the other way around, that is also perfectly fine. We should just make sure that we only keep one utility section, since the other one is not really needed. Now, the second thing that I think is redundant has to do with the unpremult nodes. They are all here, as you can see, unpremult. So what's redundant about that? Well, they have been placed, technically speaking, correctly, but since you can see that all, well, actually you can't yet, but if you do have a look now, if I do this, up here, and this one up here, right. So these are all hidden inputs, and remember, I'm going to change that a little bit. Okay, so from here you can actually see all of these shuffle nodes, where we're shuffling out all of our AOVs. They are coming from the same spot over here in our B pipe, in our main B pipe. So that means that we should be able to get away with just one unpremultiplied node if we were to place it over here. So if we place an unpremult here and we make sure that we set it to unpremult all, we should be able to just basically get rid of all of these ones here. Okay? so that's that for the redundancies, I think. Let's talk about matching blacks for a minute. So if you go in here, we can see that we have a section down here at the bottom that says match blacks. And having this is actually a really good idea, I think. Because this is one of those things that we are almost always going to have to touch when we're grading CG. At least if we are grading CG in order to, integrate it with a plate. Although in this case, I would say that I would probably want to have a little bit more room around. So basically make a larger sort of backdrop here and call it something like an overall grading section, and then simply have this matching black part at the bottom of it. So we do have match blacks here at the bottom just before the pre-melt, and that's actually the right place to have it. Because it's recommended to always do the matching of blacks as the final step in your grade, so placing it right here, that's pretty good. The reason why this is recommended is something I cannot go into detail about in this tutorial, but basically if you move your black point up to some other value than 0, any grade that you do after that or on top of that will, in a mathematical sense, be doing the wrong thing. Or perhaps said in a different way, the response of a, say, gain or gamma operation will no longer be doing exactly what you would expect it to do. Okay, so anyways, it's the right place, so that's fine, right? Well, wait a little bit. Let's have a look here. We have here a little tip that says to use the offset color picker to select the darkest area in the plate. And we have an offset color in here. This is actually something that is a little bit surprising to me, because the offset is really just an add operation, which means that whatever value or values you put into the offset up here is going to get applied to every single pixel in the exact same amount. And I have a little setup here to the side to demonstrate this. Now you can see we've got a ramp. At the bottom, we have values of 0. At the top, we have values of 1. And then obviously in between, we have, from 1 to 0 as a ramp fall off. And in this grade, we have an offset of 0.1 in the RGB. So according to my theory then, I should get an offset. Basically, I should get this value added to every single pixel in my image here. And I do this, I turn it on, and yes, at the blacks, they're offset by 0.1. The whites, they are now at 1.1. And as you can probably imagine, if I turn this off again and find a spot just somewhere in the middle, 0.474, blah, 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 blah. If I put my grade note and I turn it on again, I should see this jump by 0.1, which is exactly what I'm doing. So it's going from 0.4 to 0.57, etc. So actually, that's a good way of demonstrating that, I think. That also means that, at least for me, doing a black level adjustment specifically, that's not something I would expect to be using an offset for. Now, we do have a depth mask here as an input, which means that we are going to be affecting different areas of the image front to back differently. So maybe if the backdrop here had said something like, I don't know, grade fog or depth grade or something like that, maybe using an offset then would have made a little bit more sense. But normally, most people will want to use the lift operation to do the actual black matching, because the lift is going to affect the blacks in the image more than any other value and will leave white or the value of 1 alone. And we can have a look at that again here. So same image. And this time I have a grade node over here, and this time I'm doing that same 0.1 value, but in the lift. So if I put my viewer here and I turn this on, I enable it, then yes, at the bottom, which were black, 0, they are now 0.1, which is what I would expect. But as I said, up here, the white should be left alone, and it is. So the black, if I'm turning this on or off, does not affect white. And of course, some random value in the middle should, with the lift operation, be influenced less than what it would be with the offset. Okay, so let's have a look. So we're going from 47 to 52. Well, actually, if I look over here, we're going from 47 to 57. So you can see this is not being affected quite as much as with the offset. So that's all nice and good, I think. Now, In addition, there is an issue with this depth masking channel over here. A mask is expected to be normalized with values between 0 and 1, whereas most renderers are going to output a depth pass with real world or real unit values representing the distance between the camera and any given object in your scene. So basically not normalized, at least not by default. So let's have a look then and see in our depth over here. This AOE that's coming from here, it's being basically shuffled into the RGBA. And actually, since we are using this as a mask, we should be watching the alpha channel. And you can see that we have it in here, but the values, the lowest value we have here are basically around 1.18. And in the back, we've got, values of 3.7-ish. So this is definitely not normalized. And that's a problem. So I would say that at the very least, for this to be okay, using a depth mask input, we should include some kind of setup to make sure that our mask values are in the correct range before we apply them to any kind of grade. So actually, let's do that. Let's do a little test here. Okay, so I have my depth, but actually, the first thing I want to do is I want to do a remove node and just basically keep just the alpha so that the RGB is not confusing me. Okay, so we've got our values. We can read the values down here, and they're too high. So there are several ways of doing this, but I'm going to use an expression on the alpha channel, and I'm going to set it to 1 over A. So basically 1 divided by alpha. And voila, we're looking at the alpha channel. We're not doing anything to the viewer here, and you can see that this definitely looks more like an image that is within the correct range. And so if I have my viewer on the expression node here, we can see that the highest values we get here in the front are 80.87, so that's less than 1, and obviously back here we're staying also higher than 0. So this is now normalized, but of course it is now also flipped. So I would really rather have it flipped again so that we have the lowest values in the front and the highest in the back. And I can do that if I just go in here and I switch on my alpha, and I basically take my white point to 0 and my black point to 1. And now it's flipped again. So now I have the lowest values in the front and the highest values in the back, as we can see here. But it's still normalized. So that should actually work quite well as a mask input in general. But there are often cases where you would maybe want to do some adjustments to this fall off that we have, this front to back fall off. And the way you would do that is you would do, or at least one of the ways you could do that, is you could simply attach another grade node. And then here you could play with the black point and white point again to get an image. Let's say we want to have just a bit more separation, I guess, a bit more crunchy type of fall off front to back. We could do that. We can create a bit more contrast by darkening the front. So if we put our measurement over here, not quite as much. Now I'm almost 0, but not quite. And in the back, we can go and we can raise that until we're almost to 1. Okay, something like that. So basically we have a way where we can manually control this normalized depth mask here. Let's have a look at the result then. So basically, if we are so we have an offset here. I mean, I said normally you'd be using lift, but let's just stick with the offset for now. So if we are not using any of these tricks we have over here, the result will look like this. So basically a very, very sort of foggy and monotone result. And actually, if we just turn off the mask at all, you're probably not even going to see much of a difference. And that would be because the depth right now, as I said earlier, has the lowest value is actually over 1. So that's not really very helpful. But if I switch on the first 3 of these, we will have a normalized value, and it will be flipped back again so that we have a lower values in the front. Then we should see a big change. I hope you can see that now. That we are definitely affecting the objects in the front less than the objects in the back. We're getting a nice depth grade here. Now it just looks more like a kind of a smoky kind of room. So we're definitely affecting even the front a little bit here, but it's a lot better looking than if I switch these off. This is just basically very, very murky and monotone. Now we have some separation front to back in terms of our values. But again, if I want to have even even better front to back separation, or a sort of more contrasty fall off in this mask, we had this other node, and if I switch that on, hopefully you can see the difference here. It is now a little bit more subtle, but if we look at the bottom here and look at the very front, we can see it, at least I can see it here. Now, with the video, when it goes online, and when you are watching that, it would have gone through compression and stuff, so I'm not really sure how much of a difference you will see, but it's definitely there. So I think that having something like this in our setup, implementing something like this in a setup would be a pretty good idea. Okay, I said that if we just have a look here, I said that most people would probably resort to a lift operation here when they grade for blacks, or when they are basically adjusting their blacks. And this is what I used to do as well, but I don't anymore. Let me instead introduce you to a little gizmo that we have over here. This is called Blacks Match, and is a very, very useful gizmo for matching blacks and also for doing depth grading in general. And it's created by a guy called Tony Lyons, so props to him for doing this. As I said, very, very useful. And I know that he's got a really good tutorial on how to grade your blacks by using this gizmo. So I'm going to put a link in the description for you, and please check that one out if you're not familiar with how this works. Since Tony does a much better job at explaining this gizmo himself, I'm not going to do that here. Instead, I'm just going to switch out this grade node with the gizmo in the upcoming setup, I think. Okay, so far so good. I think we've actually been through most of the things that I wanted to talk about before I show you the revised setup that I made. So I think basically now it's time to introduce, well, that revised setup. So here we are with the new combined additive and subtractive setup. First up, because we spent so much time with the setup on the left over here, going through lots of things on it and explaining in detail how it actually works, I'm hoping that going through this new setup is going to take considerably less time. Mostly because I obviously don't need to explain everything from scratch again. The most obvious change of the setup on the left, so I do this and I do this, like that. The most obvious change from the setup on the left is, of course, the changes in the layout. First of all, as you can see, the main B pipe over here is now a straight line from top to bottom, just like in the other two previous setups. So this setup and this setup. It's now a straight line from top to bottom, no hidden inputs. It should be really, really simple and easy to see how the main data flows through the setup. And what follows from that is that the additive sections of the setup, these, the AOV sets, have been rearranged to match that B-pipe layout. In other words, they are now in a stack rather than in a row, which is in accordance with the guidelines we've been using throughout the tutorial. You could, of course, choose a horizontal layout instead, but then you should still pay attention to making sure the main B-pipe of your setup is clarified and visually easy to follow. But here we are doing mainly top to bottom types of setups, so I'm going to stick to this one. Another layout change is that I have moved my checkpoints. Now they are right next. They used to be here, and now they are here. They are right next to the point that they are supposed to check. I find that to be more useful because it gives me a better sense of exactly what I need to look at. So let's just actually do this. Let's do this. And we can check here. We know that this is checking the stuff that to do with the beauty from lights. And we have another one here. And another one here. Yeah. And they are all, if I flip through them, they're all black, so everything is still working according to plan. You could perhaps argue that it is convenient to have them really close together, like over here. And therefore, if you did that, it would be quicker to check them all. But actually, as you can see right now, I don't really find it difficult at all just to zoom out a bit and then, like this, just basically select them all and just flip through. It's not really a time saver at all, or at least not very much of a difference to this. So I actually just basically prefer to have it like this, because now at least they are at the place that they are supposed to be checking. But actually, if I was really honest, I probably, let's just do this and this again. If I was really honest, I would say that the checkpoints are included in this setup because they used to be a feature in the other setup. And although they are useful, now that I have a really good understanding of how this whole thing actually works, I don't think I even need them. So I know what to check and where to check it. So if I need to see something is missing, or see if something is missing or has changed, I can do so on the fly without any checkpoint. So actually, I think I'm going to delete them like that, because now I have an even cleaner setup than if they're in. But of course, if you want to keep such things as these checkpoints in your setups, that's also perfectly fine. There's nothing wrong with them. I just think that I prefer to not have them in. One more thing that I moved is this part with the injection of the utility passes. It used to be up here, basically just after the rebuild of the beauty, the final point of the rebuild. And what I've done now is, instead of having it up here, I've moved it all the way to the bottom here. I've also separated out the alpha part. You see here, I'm now pulling in the beauty here with the alpha. Actually, maybe we should go and do like this. So now you can see no alpha, now I have an alpha. And I'm doing that right before the pre-mult, the pre-multiplication. And then after the pre-mult, I'm injecting the utilities into the to the stream. So we can see we got the copy B box, we got the merge, and also set to also merge all. And then I got this utility pass coming in here. The reason why that is because I don't think that I really need to have any of these utility passes in the main data stream up here. I can just add them as late in the game as possible, I think. Also, since I do not have any motion vector pass in this render, or really a need for things like normals, etc. in the main B pipe, I have chosen to just inject the depth pass only. As that is the, well, it's the only thing I really need. So, for example, I would need it to do some kind of a Z focus. I would need it for that. But I don't think that I need to have any of the, I don't know, normals or position passes or anything like that coming in here. If I were to work on a show where we would need to do, let's say, motion blur in Nuke, then I would just simply adjust the setting or adjust the setup accordingly at that point. Well, something else about this setup is that, as you've probably noticed, I'm not using a remove node here. So there's a remove node in this one up here. Remember? Well, I don't really need that here. I just have the copy bbox node, but I don't really need the remove node. And that is because, like in the previous simple additive setup, over here, I have all my remove nodes right up here, and I've simply done the same in the setup. I'm taking care of deleting any passes I don't think that I need. Remember? I'm taking care of that upstream as soon as I have shuffled out the AOVs. And as a result, when we get to this point here, all I really should be having, as you can see, is the RGBA. So that means alpha, because I'm piping the alpha in here. So then again, at this point, I don't need to have a remove node. Actually, I do have one here. And that is really just a fail-safe where I'm saying I'm going to keep this and the depth. But to be honest, this can be either deleted or just disabled. Let's just disable it for now. Okay, so what's left to mention then? Well, one thing would be that I got rid of what I consider to be redundant. And that means, first of all, I have a single unpremult node here set to unpremult all, instead of the previous version of this type of setup, where we had all of these unpremults coming in after every single shuffle node. This should do the job just fine. And then the second thing that I remember talking about as redundant is that this one here has a utility section, which is a great idea, except I really only need one of them, and I prefer to have that set up here at the top. In this part, I guess you could call this something like a channel prep section, for the lack of a better word. So yes, so that means I've gotten rid of that as well. So that's done. Another thing I've changed is that I do not have any postage stamps on my shuffle nodes. As you can see here, there are postage stamps on these nodes here, but over here I have switched that stuff off because I don't really need them. If I want to see what data is coming from one of the shuffle nodes, I will just simply put my viewer on it and have a look at it this way. And, I also, basically, if I'm not looking at that, I also still can simply read what it is set to shuffle out. So this is set to C high key, and I know that is, and I know that is because I've got a TCL expression here in the label, just like that. And so now if I were to switch that to, let's say, RGBA, you can see that getting reflected over here. But it was set to high key, I think. Yeah, exactly. So that's normally more than enough for me. Another thing about this is that it could be that Nuke's performance will suffer somewhat if you have a lot of postage stamps active in your scene. So for that reason as well, I tend not to activate any. The only thing that remains then in terms of an overview is actually the stuff down here, where I have done, as I said, I have switched out the grade note for this for matching blacks that was in there earlier with the blacks match gizmo. And I now have this gizmo in the setup right before the pre-melt. It is disabled because I don't want it to do anything by default, but it is in the setup to remind me that matching blacks is almost always needed. Okay then. I believe there's actually one more thing I would like to add when I'm looking at this. I think it could be a good idea to simply add that little setup for creating a normalized depth mask that I did earlier on the previous version. So let's just do that. For that, I think I'm just going to take not the beauty, but actually this one up here. So this is my depth pass coming in here. And I think it's still around. Yes, so I can simply steal that. And then do a dot, move that over here. Do another dot. We can disable this and then actually let's have a little look. Whoops, not like that, but like this. And so here we have the depth coming in like that. Good. That means that I should be shuffling that out. In this case, I'm going to shuffle the depth into my alpha. So now it should be in the alpha. Here it is. Okay, and then, I don't really need that one in this case. So now I've got my alpha here. Yep. It has been normalized, then it was being flipped, and then we have this one here where we can do some grading on that mask. Let's make sure these are set to be clamped on the white as well. And then I can simply write, let's say, what should we call it? We should call it a depth normalized depth mask, I think. And make it a little bigger. Yeah, I think that should do it. So now we have both the actual Z depth coming in here for our, or not the Z depth, the depth AOV coming in here for our Z defocus, as well as a mask that we've been normalizing that is ready to do some kind of depth grade if you want to do that, or if you need to do that. Good. And with this in place, I think we are good to go as far as this setup is concerned. The next thing we will need to do is to do a functionality check to make sure that things are still operating in the same manner as they were before. So that's up next. Hi there. So let's quickly make sure that everything still works as expected. We should then basically just go up here and start at the top. Let's do this. Right, so we can see that we're getting our beauty coming in here. Remember, we're shuffling in RGBA. So no beauty, beauty. Okay, good. Passes are going off to the side. That's fine. Then we have a remove node set to keep RGB so that we don't, have all these passes anymore. That's according to plan. Okay, good. then next here, we should have our first black frames. Let me do this for a second. Yeah, let's get rid of that. Okay, so we have our black frame here. And as you will remember, this here is our new baseline, basically. And of course, it is done by doing this, summing up all these passes in a plus and then subtracting them from our beauty. We get this black frame. And as you can see, we are getting that little pixel difference again. I mean, I can gain up a little bit. This stuff here is still in there. So that's all the same as before. And then the next step was that we should then take our beauty reconstruction here, or our reconstruction. And then we simply add that, we plus that onto this black frame. And we're good to go. Now we are, if we look and compare to the beauty, I remember there was a spot here that's good to see. See, I'm flipping back and forth and we are identical. So this then would be our new current beauty. I think that is what I refer to them as. So far, so good. And I guess, when you look at this, so if you look at it a bit closer, it's no secret then that what we're looking at here is what we're going to repeat again in these next step, which is pretty much what we did before as well. So we can expect then that from this beauty, we are going to get to the next stage with the next, in this case, the material AOV set. And we get another black frame, brilliant. And then we reconstruct again, brilliant. This is all, plus. Also, we have kept the horizontal daisy chaining here for the reasons that I talked about previously. I didn't really want to have just one on this particular merge node, so that's kind of a small change. Then we get to the third black frame, and remember, we are still picking up this difference because for the direct and indirect lighting contribution stuff, we are missing these two passes. So that's also the same as before. And again, we take then the result here, we add it back into the stream, and we are at the final reconstruction, basically. So the only thing that's below that is an overall grading section, which we just had a look at before. So that means from the construction, we are doing the exact same as before. All right, so the only thing we really need to do then is to throw in a couple of grade nodes and actually verify that we can grade across the AOV sets again. So I don't know, let's just put one in here, put one in here, put one in here maybe. And let's just move some sliders around. Okay, so this is, you can see it's here. This is basically a lighting group pass, and it is a fill light from the left, I think. So we're grading on that. And here, what's that? Transmission. Okay, good. We can grade on that again. So we see some response here. Actually, let's try and do the diffuse because that has data everywhere. So let's take the diffuse. So it's also going to grade, on top of whatever we changed above. So let's try and do that. Can we see that? Yes, we can. Nothing is breaking. This is looking pretty decent. And in the third set, indirect diffuse. Okay, yeah, let's do that. And you can see here in the front and down below here that that's also working as expected. Hopefully you can see this pretty good. Right then, that means that we can grade across these AOV sets, which is exactly what I wanted. And that means that, well, we have that, plus we've already gone through all the changes that I made. So I guess we can now say that, as far as I'm concerned, this setup is actually ready. Let me just delete these nodes here. Don't need them. Get rid of the grades again. Boom, done. Yeah, it's now ready. And by ready, I do mean ready for real production work, if you wanted to do that. And I can also say that this type of setup here is something that you will find out there in many companies already. They might not look exactly like this. They might have a different layout. They might implement the subtractive principle here in a slightly different manner. But in the big picture, as far as methodology goes, there are many setups out there that will be working in a very, very similar way. So this is a very flexible setup. It's pretty, yeah, I really like it. It's good for production work. And I at least have seen this type of setups in multiple examples in multiple productions over the last few years. So I guess that with this, we are done with the combined additive and subtractive CG grading setup. Or are we? Hold your horses for a minute and let me talk to you again in a second. All right, so here we are again. As you can see, I've deleted the first combined additive and subtractive setup from my script, and I've just kept this revised setup because I don't really think that we need them for the demonstration that I'm going to do. Okay, so just before I said that the combined additive and subtractive setup is finished, and then I sort of added a question mark to that. So why is that? Well, first of all, the setup is actually finished, and it does work as it's supposed to work. But nonetheless, there is still an issue. And this issue is actually kind of a feature of the setup and not really a bug. So that sounds a little bit mysterious, right? Well, I'm going to have to demonstrate it to you, and then hopefully things will become a little bit clearer after a while. So, therefore, let's just imagine a scenario where the director comes to us, takes a look at this, or, the client or supervisor, look at the image, and then they go, we think that the shot is too bright in general, we want it to be darker, and we don't like that left fill light over here. Can you please kill that? Also, I think that the diffuse probably needs to come down as well so that we have an image that's a little bit more reflective, but we don't really want to see too bright a reflection either. And also, as you're working on this, can you also please just reduce the key light in the scene as well? So I know that this sounds a little bit on the ridiculous side, but let's just go for that kind of a scenario for now. And we want to try and make our director happy, of course. So I put in a couple of grade notes. They're not really doing much at the moment, but let's just start working. Okay, right. So we got the key light here. That's supposed to come down a bit. So let's put that down. Okay, something like that. And then we have the fill light. We want to kill that. Then don't need it. And then I said diffuse. Okay, that goes down as well. Something like this, maybe. So now the image is darker and we're left with just sort of reflections, but maybe the reflections are a little bit too bright as well. So we want to take those down, and the indirect reflections, we want to take that down as well. Something like that. Okay, something bad has happened here. You might already see it in this image. It's a little bit dark, but let's gain up the viewer to see that something actually really bad has kind of happened. This image now is, well, for the lack of a better word, is kind of just destroyed. We've got these weird blue colors over here. We got some dark patches all over this one, a little dark spot here as well, and just like, in general, very, very bad. This image looks really bad. So if we look at this one here, if you measure, we can see why. Here, we really only have blue colors in the positive area, and both the red and the green channel have gone negative. And over here, I guess you can imagine, it's black, so that means that all our colors in this region have gone negative. Same thing here, we see up here, let's see what's here, well, negative, negative, and this one as well. So basically, we have managed to completely destroy this image with our grade, especially because we've been grading across these multiple AOV sets. So now you might be thinking to yourself, what is happening here? We've darkened it the way the director wanted, but by doing so, we've managed to just kind of completely destroy the image. So again, what's really happening? First, I will have to show you something over on the simple additive setup. If we go over here for a second, and we look, I've got a bunch of grade nodes in here. I can enable them, and if I click Alt-E, I can see here with the links that these are all clones, which means that if I grade one of these, I'm going to grade all of them, just for demonstration purposes. So let's do that then. I'm grading down, and predictably, as you can see, if I grade them all completely down, I just get a black image. So we don't have any information anymore. In other words, in an additive setup like this, if I grade everything towards 0, the lowest value of my output image will get is going to be 0 or black. And conversely, right now they are grading everything together, but let's just, for the sake of argument, let's just imagine that I only graded some passes down to 0, I would still see the rest of the information from the other passes that have not been graded down, and therefore I would not go as low as black in my pixel values. So in that case, pixel values would be staying in the positive domain. So that's the first thing to remember. Now let's go back to the setup we have over here, and let's disable these grade nodes. Okay. If I now zoom in a little bit and I look at this part here, let's just right now call this a box. I could say that the sum total of the data inside this box is represented to me as the beauty, if I look here. But if we look at a second box, the sum total of data inside this box is also represented to me as a beauty. Okay, if I flip back and forth between them, I can see that they are indeed equivalent. However, here, the sum or the subparts inside these boxes, or inside these AOV sets, whilst they are all representing some partial contribution to what ends up being the final image, they are split out according to different criteria and are thus not equivalent. Now, the criteria here being lights and the criteria here being material AOVs, okay? So that's to say that any given AOV from one set, here from one set cannot be equivalent to any given AOV from another set. But of course, they are related. If you think about it, you can't really have any pixel values other than 0 if you have a scene but you have no lights, okay? You'll get black. Conversely, you can't have pixel values other than 0 if you have lights in your scene but there are no surfaces with materials. You also get black. So all of these things are related, but they're not the same. To reiterate then, the AOVs here are related because they all represent pixel data or information that goes towards creating the final image that we can view here, for example. But they are not the same because they represent that data according to these separate criteria. So that's the second thing to bear in mind. Now, if we then stay within one AOV set, basically within one criteria, and we do our darkening grade only there, we have the case that I showed you over here in the simple additive setup, because of course in this setup, this here is the additive part. And that would mean that the lowest value we then go is this black frame that we're going to get, the baseline if you like. But if after we've done the first grade, so we grade something here, and then we choose to add a second grade in a different set, in other words, we're doing an additional AOV grading according to this different criteria that I talked about, that is when we could get into trouble. Let me show you this in a more abstract or conceptual way. As you can see here, we have basically a graph. We see that we got the indication that positive numbers are going to go up, negative numbers are going to go down here across, or basically along the y-axis, and we therefore have a kind of a 0 point line here. Now we've got a column, and at the top this little square here. Let's just say that conceptually this is sort of represented as any given pixel in our scene. And the column then, of course, represents its arbitrary value in the positive domain. Okay, so, it represents a pixel color, or let's just say for the simplicity's sake, a luma value. All right, and then if we play this a little bit, we can see that we have a second column here, and this is sort of one of these boxes as I talked about. Think of this as a one AOV set, and each of these three colors represents basically one AOV within this set. The size of it, obviously, as you can see, is basically corresponds to the amount that it contributes to the final value of our pixel value. And by the way, this pixel value here is indicative of the pixel value as it comes out of our set, or out of our final grade, basically. That's why, wait a second, so we go back again here. So that's why it's the final beauty in the end. Right, we decide we want to grade this a little bit. And as you can see here, I was a little bit too quick. But let's start to grade this pixel down. So we grade according to the first one here. And then you can see that the pixel value obviously responds correspondingly to how much we're grading down. And then we grade the second one down, and we grade the third one down. Okay, great. As you can probably already see and imagine, no matter how far we grade these, this final pixel value cannot really go any further than black. So that's basically the same situation as I just demonstrated in the simple additive setup. Because we are staying inside this box, inside this AOV set, where things have been split out according to a given criteria. Let's just call this our light passes, for example, our light group passes. So that's all good. Our pixel value has been graded down, but we're still not quite happy. Let us imagine that we then decide that we're going to add a second grade, or that we want to darken this even more. So then we add a second AOV set to the mix. And again, this represents basically the value that the pixel would have in the beauty coming out of this AOV set. And we have not yet, like over here, we've done the grade already, but we haven't done any grading here. So let's pull these down like this. So now we're going to continue grading. And you can very quickly see, yes, we're already landing in negative land here with this pixel. And then we grade the second one and the third one. And the more we do so, of course, the problem is going to get bigger. So the reason for this is that we are using a subtractive process. So if I go up here, click here, we're using the from in order to create this baseline of black. Of course, the subtractive process basically takes the or compares the beauty, the rendered beauty, with in the case when we're doing grading the graded beauty. And if we don't have any grades, well, then we're just going to get a flat black, our baseline. But if we do grade, well, the grades that we do, the grading that we do, will register as the difference between the rendered beauty and the graded beauty, where positive numbers will indicate that we have brightened pixels, and negative numbers will indicate that we have darkened pixels. And because of the subtraction, we have to allow for these negative numbers. And because of what we might encounter, or because of that, we might encounter negative pixel values when we grade across multiple AOV sets. The subtraction itself, this here, is a feature of this set. So we can't really escape this possibility entirely. All right, then, you say, that's a bummer. But what does it actually mean in practice? Well, I would say the following. Number one, if we grade, and we really only need to grade values up, well, then we have no problems with the setup. We can grade across everything, we can grade all our AOVs, everything is going to be fine. So grading basically pixel values up, that's not going to be a problem. Number two, if we do any severe grading of AOVs, and we do so inside just one set, or one AOV set, well, then you're still good to go, because then we have the same situation as we had here. Because this here is the sort of simple additive part of our setup. So we're going to be fine if we just, decide to stay just inside of one set, or grading according to just one criteria. Number three, though, if we do darkening across multiple sets, then we could potentially encounter the negative pixel value issue, and we would have to be vigilant about what we're doing. If we actually encounter this issue, or if we don't encounter it, it's going to depend on A, the render itself, how it looks, because of course all images are different. Some are brighter, some are darker. And B, how much we're actually going to grade it down. So if I spool this back a little bit and we just have a second look, we've done our first grade, and our pixel value is this value. Well, when we do our second grade, you can see that in the beginning, we're still, with our pixel, we're still in the positive, on the positive side of things. So we can actually grade a little bit down, but we need to be vigilant and make sure that we don't do too much grading, basically, or too much darkening over multiple sets of AOVs. Okay, now if you say this is not really great news, is it? You would be right. I also think so. I have had this issue multiple times in multiple production over the years using various kinds of setups that use this principle. There are several ways of building setups that are in their details a bit different, that looks different from this, but ultimately that do use a subtractive process. And all of those setups, at least all that I have encountered, do have this problem. Because, of course, the subtraction is integral to the setup, how it works. They all will have this problem. I have not yet seen any issues using, or I have not seen any setups using this principle that don't have this issue. Now, maybe there are some super brains out there who can find a way to kind of counter this in a clever way. But at least in the last few years, I have not really worked with setups that do this. So that's not so great. The question, though, is, of course, can we fix it? Or can we create something that is better? Well, again, we can't really fix this setup, or we can't get rid of this issue in the setup because of the subtractive process creating a baseline around 0, where it's necessary to keep negative numbers. They always have the potential to go below 0. But there is a solution, and we can actually create a setup that will solve this particular issue. It's not going to be exactly the same setup that you're looking at now, but we can create one that solves it. And that's what I'm going to show you next.